Welcome to solverfy.
This is chapter 27, problem number 66. We are given a wire that has a current along positive z direction. So let's write the L vector as L k hat. And then there is a magnetic field acting on it. The magnetic field has x, y, and z components. We are asked to calculate the components of the magnetic force generated by this external magnetic field. So the force, as we know, equals to the current times L vector cross product B. So then what we have is basically based on the components. I had J hat, K hat, 0, 0. For L, we only have the Z component, so it's L here. And we have the X, B, Y, and BZ. Now I hat, it's going to be 0 minus BY times L minus J hat is going to be equal to 0 minus BX times L plus K hat. As you can see, 0 times BY, 0 minus 0. So we don't have a Z component for the force. So then what we have along X direction is negative BYLI I hat. And negative times negative is positive BXLI J hat for our force. So this term is the X component, this term is the Y component, and as you know, we have the Z component that is equal to 0. So then F sub X is going to be negative BY times LI. When we plug in for BY, it's given to us as negative 0.985 Tesla times the length of the wire is given to us as 25 centimeters. So I'm going to do the conversion to meters. And the current is 7.4 amps. So the F sub X would be 1.82 newtons. When we do the calculation for F sub Y, that equals to BXLI, then BX is given to us as negative 242 Teslas, and then 25 centimeters. Again, the length of the wire, we're converting it to meters. And then we have the current, 7.4. So we find the Y component of the force to be negative 0.45 newtons. And now in part B, we are asked to calculate the F net. So the net force then is going to be equal to the square of the X component plus the square of the Y component and square root of the summation of these two terms. Right? So then F sub X was 1.82 newtons and F sub Y was negative 0.45 squared. When we square this, we're going to get something positive. So we find total force to be 1.87 newtons.